Hey everyone, it's Paul Bertorelli reporting for AVweb. You know, if you've got much flight time at all, you have probably noticed that a good landing is usually preceded by a good approach. But a good approach doesn't necessarily assure a good landing. And I found that in tail draggers like this Cub, I really need to be exactly on speed through most of the approach in order to get a good 3-point touchdown, and even then, some landings are better than others. Now in the Cub, I tend not to use the airspeed indicator that much because it's not very accurate or consistent. So I do what a lot of old tail dragger pilots do, which is to fly the wing, and that's another way of saying that I'm setting the pitch attitude by eyeball. I know, for example, that that's too low and my approach will be too fast, and that's too high and the approach is going to be slow and I risk a stall or a mush. But for most approaches, this is just about right. So that's the sight picture I'm looking for on a typical approach. Now, a Bonanza pilot would understandably sneer at this because Bonanza pilots have better airspeed indicators. But they also have something else too. And it's called an angle of attack indicator. I'm sure you've read or heard about these devices. There are several on the market, and in this video, thanks to Dan Gulandry and Sarasota Avionics, we're going to take one offered by Aspen Avionics for its Evolution line of electronic flight displays. Here's what the display looks like. It can be set up to pop up only when you're nearing a critical angle of attack, or you can have it display constantly. I prefer the latter. How you add it to the system is really pretty clever. It doesn't require any additional hardware, just a non-airplane specific software package. Once that's installed, you fly through a calibration procedure that considers the airplane's weight, stall speed, approach speeds, and a few other parameters. The system then uses its solid-state gyros and air data to infer angle of attack through an aerodynamic model. The AOA is also inferring something else, coefficient of lift, which is a direct function of angle of attack, as shown in this graph from Aspen's data. Let's go back to the display and see what that looks like. It's simple, but it requires some explanation. The AOA scale range is expressed in a single vertical tape with 2 pointers. One is for flaps up AOA, and one is for flaps down. Here we've got the flaps up. In cruise flight, which we're in now, the pointer either fades away or drops down into the blue zone because the angle of attack is considered non-critical. As AOA increases, the pointer rises through the green toward the yellow and eventually into this crosshatch area, which indicates minimal margin against an impending stall. And here's what the full stall looks like and feels like. Now, as I mentioned, the AOA system is inferring angle of attack, not actually measuring it with a vane-type sensor. It's also capable of inferring load factors, so a steep bank will move the needle higher into the green, indicating less stall margin, as you can see as we enter a steep bank. When the indicator rises, so does the lift coefficient, so the AOA is doing what Aspen intends, which is to provide a visual indication of stall margin. But here's where I'm going to go off the reservation a little bit. The military, especially the Navy, is big on using angle of attack indicators and indexers to help pilots with on-speed approaches, which is obviously important for a carrier landing. That's not exactly what Aspen has in mind for this AOA, but it can be used for that. Let's take a look. First of all, you probably know that stall angle of attack is independent of weight, but indicated stall airspeed isn't. The lighter the airplane, the lower the indicated stall speed, with some exceptions. What that means is that when the airplane is light, the airspeed can be adjusted downward with the same stall margin. Most of us don't do that, so we end up flying approaches a few knots faster than necessary. Too fast approaches are more likely to result in too fast landings, and those can get ugly. And even if they don't, they use up more runway than is really needed. That matters if you're trying to do a short field landing. To test this, we can set up a short field approach using the recommended airspeed for our weight, which is about 63 knots, and then see how much stall margin the AOA indicator says we have. As you can see, it actually says we're in the green, so there's surplus margin. Unless you're really nervous about stalling, increasing the angle of attack will put the indicator in the green-yellow transition, which Aspen says corresponds to the short field approach airspeed. You can see that the airspeed indicator actually indicates a speed lower than the published recommendation. At altitude, you can experiment on how far into the yellow you can go before either getting on the backside of the power curve or reducing the stall margin beyond your comfort level. Now, as I said, Aspen isn't necessarily intending the AOA to be used just this way. It's really for stall awareness. But as the technology matures, and more importantly, the training doctrine catches up to AOA technology, you can definitely see the potential. For AVweb, I'm Bertorelli reporting. Thanks for watching.